So, students, all of you know what is a circle. You have studied about properties of circle in lower classes. You know what is a circle. A circle is a collection of points which is equidistant from a fixed point. If I talk about a circle, this is a circle. And this is what? This is collection of points. On this circle, there are several number of points, right, which are at equal distance from the fixed point, and that fixed point we know is called the center of the circle, right? So, what is a circle? How do we define a circle? Circle is a collection of points which are equidistant from one fixed point, and that fixed point is called the center of the circle. You know this. This is not new. This is just a revision what we have been studying in lower classes. Then, a line segment joining the center to a point on the circle. This is a point A on the circle. This is called what? Radius. We all know. Yes? What is the radius? How do we define a radius? We are not going to write down the definitions. Alright? Radius is a point, line segment joining the point on the center of a circle to a point on the circle. And all the radius of the circle are equal. We know that. The radius of a circle is equal. Correct? This is the point B. This is point C. So OA, OB, OC, they are all going to be equal in length. That is the radius of a circle. The line segment joining center to a point on the circle. Center to a point on the circle. Center to a point on the circle. Sorry. Now, after this radius, you have another line segment joining 2 points on the circle and passing through the center. This is a line segment PQ. It is passing through the center and it is joining 2 points on the circle. This PQ is called the diameter of the circle. We know that diameter is double of radius. D is equals to twice of R. We know that. These are properties you have been doing in lower classes. Just the division. And this line segment that is touching 2 points on the circle, or in other words, that is connecting 2 points on the circle but passing through the center, is called diameter. And this line segment is also called a chord of a circle. What is a chord? Line segment joining 2 points on the circle. This is also a chord. MN. M is on the circle, N is on the circle. This is also a chord. This is another chord. X, Y. So what is a chord of a circle? Chord. Line segment joining 2 points on the circle. Correct? Now the question arises, so then this diameter, is a chord? Yes, diameter is also a chord, and diameter, the only difference between the diameter and the chord, that the diameter passes through the center. That is why that chord is called as diameter. PQ, diameter is also a chord. Diameter is a chord, or in other words, अभी से डिस्कस कर लेते हैं, is the longest chord of the circle. Longest chord of the circle. Clear? How it is longest, we shall prove it in our theorem portion. Not to worry. So, radius, diameter, chord. In this class 9, we are going to discuss about properties of this chord. Correct? Then there are few things that we need to discuss. If you take a look at your page number 170 of your NCERT book, there you will find few things we will be discussing that. Now pay attention. Arcs. You can see if I remove this line XY from here, this chord XY from here, right? Now you can see this MN. This MN, is it dividing this arc into 2 parts? This circular arc into 2 parts? This is called the minor arc. And we symbolize it? Minor arc MN is symbolized like this. Clear? Right? And the remaining portion, remaining circumference of the circle, this remaining circumference of the circle, this is your major arc. Minor and major, smaller and big. You can see that. Same way, this circle is also divided into sector and segments. Check. This is the circle, center O, and these are two radiuses, OA and OB. These two are radiuses. So can you see this area that is bounded by these radiuses and this minor arc? The area that is bounded by this is your minor sector. Minor sector. Correct? And this unshaded region is your major sector. This will have a complete chapter in your class 9. Complete chapter is based on this sector. Right? Same way, one more, when this circle is being divided into two parts by one line segment, and that line segment is the chord. You can see this chord AB. It is joining 2 points on the circle. So this chord is dividing the circle into two parts. This is one major part and this is smaller part. This is called segments, minor segment, and this is your major segment. Again, we shall be discussing about the areas, the formulas related to minor and major segment in class 10th. Clear? Very, very important. Very, very important. Now, another line segment that is there, other than chord, say this. Two more line segments are there from which you will going to be study. This is the center of the circle, say O. Right? And this is the line segment that passes through the circle. It is intersecting the circle at 2 points, but it is passing through the circle. This is called a secant. The properties of the secant are not a part of your syllabus, so we are not going to discuss that. This is called a secant. So can you see the difference between secant and chord? Chord has 2 endpoints on the circle. It does not pass through the circle, but a secant passes through the circle. It connects 2 points on the circle. It passes through 2 points on the circle. That is a secant. Secant crosses through the circle. Chord has the endpoints on the circle. Chord has 2 endpoints on the circle. Secant intersects the circle at 2 points. Whereas one more is there, one more line segment is there, which is not a part of your syllabus in class 10, but we shall discuss that. A line that touches the circle at one and only 1 point. One and only 1 point. This is the line segment that is touching the circle at one and only 1 point. This is called a tangent. The properties of this you shall be discussing, you shall be studying in class 10. It is a part of class 10 syllabus. Clear? So these are the line segments on page number 170. You will find the entire thing, interior point, exterior point of a circle. All of you know a point on the circle. These are the points on the circle. 1, 2, A is also there, B is also there. These are on the circle. When a point is this, these are interior of the circle. Right? And when a point is outside the circle, we say it is the exterior of the circle. Right? We don't need to discuss all these. You know what is interior and what is exterior. Right now you are sitting in the interior of your house, interior. And when you come out, we are outside the house, that is we are exterior of the house. Right? So these are the things that we are going to discuss. The most important part that we are going to discuss is about the chord of a circle. So if you see exercise 10.1, simple true and false fill in the blank questions are there. You can solve it on your own. It says the center of a circle lies interior, exterior, definitely interior. The point whose distance from the center of a circle is greater than its radius lies outside the circle. If the distance is greater than the radius, definitely the point is outside the circle. So all these questions you can do. The important part that we are going to discuss today is your theorems. The important part of this chapter is your theorems. There are many theorems in this chapter, students. Lots and lots. There are around 13 to 14 theorems, of which we are going to prove all the theorems, most of the theorems that are part of your syllabus. Alright, and we will prove it parallelly. Parallelly means, now take a look at page number 172 and 173, theorem number 10.1 and 10.2, today's topic. Theorem number 10.1 and theorem number 10.2. Correct? What does it say? It says that equal chords of a circle subtend equal angles at the center. I am not writing down the statement, you have to write down the statement. Equal chords of a circle, this is a circle, and there are equal chords. This is the center O, and chords, equal chords. Say this is one chord, this is another chord. This is chord A, B, and this is chord C, D. They are equal. Right? So what is given to us? We are given chord AB equals to chord CD of a circle with center O. What we have to prove? We have to prove that they subtend equal angles at the center. Now subtend, where are they subtending? Just observe. These are the two endpoints. If I join them to the center, can we see an angle? AOB. Similarly, when this endpoint of these two chords C and D, can we see this angle? So we need to prove that this angle AOB equals to angle COD, for which construction not required. Alright, this is what we need to prove. Angle AOB equals to angle COD. Equal chords, since these two chords are equal, we need to prove that they make equal angles at the center. They subtend equal angles at the center. Whereas in theorem 10.2, read it, it says, if angles subtended by the chord of a circle are equal, this is a circle and this is the center. These are two chords as usual in the previous question, A, B, C, D. They subtend equal angles. The angle subtended by them is equal, he says. This angle is equal to this angle. What is given? Given chords subtend equal angles at center. That is, angle AOB equals to angle COD. What we have to prove? We need to prove that these chords are equal. We need to prove that chord AB is equals to chord CD. So check, both these theorems are there on the board for you. They are converse of each other. Here he is telling you that the chords are equal. Here we have to prove that the chords are equal. Here he is telling you prove that the angles subtended by the chords are equal. Here he is given that these angles are equal angles. Clear, students? Very important theorem. So now how will we prove it? Question arises. So for this, in class 9, you have done congruency of triangles. Congruency of triangles is not going to leave your part. It is always going to be there in class 9 as well as in class 10. So be prepared for that. So check, can you see these two triangles? This is what we need to prove. Angle AOB equals to angle COD. This is what we have to prove. Can you see two triangles? Take these two triangles, proof. In triangle AOB and triangle COD, what are the things you find equal? First and the foremost thing you find, sir, these two chords are equal. One side of the triangle is equal. Given to us, chord AB is equals to CD. Given to us in the question. Yes, and check the rest of the sides. What is this OA? Radius. What is this OD? Radius. Are the radius of the circle equal? Yes, sir. The radiuses of the circle are equal. The radius OA OA equals to OD, radii OB equals to OC. You can write down equal radii, plural of radius, equal radii of circle. So therefore, triangle AOB is similar to triangle COD by what similarity? S. Side, side, side. All three sides of the triangle are respectively equal to all three sides of the other triangle. So if two triangles are congruent, their corresponding angles are also equal. So therefore, angle AOB equals to angle COD. Reason CPCT. We have done in triangles chapter. What do you mean by CPCT? So this angle is equal to this angle. Correct? Similarly, when we come down over here, we need to prove these two triangles congruent, nothing else. Proof. Write down whatever is given to you. In triangle AOB and triangle COD, is this angle equal to this angle? Given to us angle AOB equals to angle COD, that is given to us. Right? And same over here in this question, is this radii equal? All of them ortho radii. So, OA equals to OD and OB equals to OC. That is the equal radii. Equal radii. So therefore, triangle AOB is congruent to triangle COD by what congruency? By what congruency? Side, angle, side. SAS. And if these two triangles are congruent by SAS congruency, so therefore we can say, will the third side automatically become equal? CPCT. So therefore, AB is equals to CD. Reason CPCT. Both the theorems are converse of each other. Students, very important parts. From this, the two theorems, your exercise 10.2 is depending. Here we have proved it in one circle. There he is telling you to prove it in two congruent circles. Congruent circle means the radiuses are equal. That's it. Clear? Let us come down to theorem 10.3 and 10.4. Again, very important theorems. Both the theorems are very important. Their application is extremely important. Theorem number 10.3 and 10.4. I am proving these theorems, students, for you. Please do it in the notebook. They are very important. Please practice them. Check what does it say. The perpendicular from the center of a circle of a chord to a chord bisects the chord. Theorem number 10.3. This is a circle, center O, and this is a chord, say AB. What is given? We are given circle with center O and OM perpendicular on chord AB. OM perpendicular on chord AB. What we have to prove? We need to prove that this perpendicular OM bisects the chord. What does he say? The perpendicular from the center of a circle. The perpendicular from the center of a circle to a chord bisects the chord. So we need to prove that OM bisects chord AB. In other words, we need to prove bisect means dividing it into two parts. We need to prove that AM is equals to BM. Construction and proof. Let us check question theorem number 10.4. What does he say? It's converse of that. The line drawn through the center of a circle bisects a chord is perpendicular to the chord. This is a circle, center O. this is a chord and this is a line, say OM, AB. What is given over here? Here we are given circle with center O, and OM bisects AB. OM bisects AB, that is AM is equals to BM. This is given to us. And what we need to prove? We need to prove that OM is perpendicular to AB. That is angle OMA equals to angle OMB equals to 90. Perpendicular means we need to prove these two angles 90. Can you see? They are converse. Here we say that this is perpendicular. Prove that this perpendicular is dividing it into two parts. AM equals to BM. Here he is already telling you that this line, not perpendicular, this line is bisecting. That means these two parts are equal. That is already given. Then prove that this is perpendicular. We need to prove that this is 90-90. Converse of each other. I said we will be proving the theorems parallelly because they are converse of each other. They are related to each other. The perpendicular from the center bisects the chord. The line segment bisecting, dividing the chord into parts is perpendicular. Clear? So very simple, as I stated. First of all, construction: join OA and OB. Join OA and OB. Can you see two triangles? Prove them congruent. If this is 90, automatically this is 90. In triangle AMO and triangle BMO, observe what you find equal. You just have to observe what you find equal very easily. Can you see one angle 90-90? Angle AMO equals to angle BMO equals to 90. Reason: because OM is perpendicular to AB, that is given to us in the question. Right? Secondly, is the radius equal? OA, OB, is it radius? Yes, sir. Radius OA equals to OB, and observe it carefully. It is the side opposite to 90 degree. Opposite to 90 degree. Yes. So it is what? Hypotenuse. It is hypotenuse of right triangle, and it is also the radii of the circle. So definitely it is going to be equal. And can you see this side OM? Is this side OM a part of both the triangles? So OM is equals to OM, that is common side. Common side. So what congruency? So therefore triangle AMO is congruent to triangle BMO by what congruency? Right angle, opposite to right angle hypotenuse, and the common side RHS. We have studied all the properties RHS, and if these two triangles are congruent, will the third side become equal? Yes, sir. So therefore AM is equals to BM. Reason CPCT, that is perpendicular from center bisects the chord. Clear? We proved two triangles congruent to show that it is bisecting. Similarly, here also we will prove it congruent, nothing else. Construction, the only property of congruency will vary. What construction? Join OA and OB. Join OA and OB. Proof. In triangle AMO and triangle BMO, what are the things we find equal? Is AM equals to BM? Given to us. AM equals to BM, that is given to us in the question. It's already given that the line segment is dividing this into equal parts. Then is this OA equals to OB? The radius OA equals to OB, that is the radii of the circle. And lastly, is this side OM common? OM equals to OM, that is common. So therefore, triangle AMO is congruent to triangle BMO by what congruency? S. All three sides of the triangle are respectively equal. All three sides are respectively equal. So therefore, they are congruent. And if they are congruent, are these two angles equal by what property? CP. So therefore, angle AMO is equals to angle BMO by what property? CP. And we are assuming these two angles to be as x. Why is x? We need to prove that they are 90 degrees. They are perpendicular to each other. This is what we need to prove. So let us prove. Let angle AMO equals to angle BMO equals to x. So therefore, at point M, angle AMO plus angle BMO is equals to 180 degree. Reason? Linear pair. They are on a straight line. Can you see that? Angle AMO and BMO, because AB is a chord, it is a straight line. So therefore, both these angles give the sum 180. Now, are both of them equal? We have already proved. What is the angle we have taken it as? X. So substitute x plus x is equals to 180. X plus x, 2x is equals to 180. So therefore, x is equals to 180 upon 2. 2 is in multiplication, 2 is in division. So therefore, x is equals to 90. So therefore, angle AMO equals to angle BMO is equals to 90, since both of them are equal. What do we know? That means these angles are 90. So is this OM perpendicular on AB? That is what we have to prove. So therefore, OM is perpendicular on AB. Converse of each other. Here he was telling you that OM was perpendicular. Prove that the chord is bisected. Here he was telling you that since the chord is bisected, prove that the angles are perpendicular. Students, you are to be very careful in proving these theorems. They are very important. Theorem number 10.5 we don't need to prove, we need to understand. What does it say? There is one and only one circle passing through three given non-collinear points. One and only one circle, application of the same theorem. We know when a circle is there, 3 points are there, 1, 2, 3. These are non-collinear points. They are not in a line. They are not in a line. So how many circles can pass through it? One. Sir, why? Or how? Right. Join them. If we join these points A, B, C, and I join them, let these points be the chord of a circle A, B, and B, C, which is passing. So the chord, the center, the perpendicular bisects the chord. If I draw the perpendicular bisectors, you have done bisector of a line in class 7 and 8. These bisectors will be meeting at the center of the circle. Why? Here it is. So perpendicular passes through the center. So just that we will be getting the center, and OA, OB and OC will be treated as radius, and we can make only one circle. So that is theorem 10.5. We don't need to discuss much upon that. It is already discussed with you. You can check it out in your notebook. We don't have to prove that. Right? Based on theorem 10.3 and 10.4 statements, you have your exercise 10.3. Don't worry about these exercises. We'll be doing questions which can be asked in the exam. Please mention the statement of your theorems in your notebook. Then only do it. Clear? Then comes most important theorem 10.6 and 10.7, which we shall be discussing in the next class. Thank you.